circuit, if you are having some trouble seeing that, is going to run, if we go by our math, right? The conventional, or by that video, the conventional thinking is positive to negative, right? So our current is flowing from positive to negative. Okay. But what's really happening is there's an imbalance across this battery, and electrons are stacked on one side and not on the other. Okay. They're actually stacked over on this side. That makes it the negative. And they want to balance out, so they're going to flow the other way. Okay. But that's actually beside the point, because as long as you understand that electrons are flowing through the circuit, you are A-OK until we get to AC, and then it will blow your mind. So hopefully a few of you I get to teach. We haven't quite decided how we're going to accommodate you guys, since you'll be doing B semester next semester. So in any event, we have a basic circuit, and the circuit has some very basic elements to it. We have the battery, of course. Let's change that color. We've got the battery that's providing our imbalance that pushes or motivates our electrons to move. And that force is called what? As a review, because it's electro and it's motivated, it's going to be volts. Yeah, I always do that. And because we use the term electromotive, we label it as E. Okay. What is another very important element in this circuit? Well, you got the wire, and we call that conductors. CT. If you can read that. All right. And then we have our resistance, right? And in this case, that's R1. And I always dot my 1 like that. It's a old habit. And that is measured in ohms, right? So the little upside down horseshoe. Are there any other elements to the circuit? Well, not really elements per se, but there is a defining factor to this circuit. Whoa. And that is that all the electrons are forced to go through all the resistors. So it goes back to that bottleneck analogy, right? It bottlenecks, and then it widens out, and then it bottlenecks, and then it widens out, and then it bottlenecks, and then it widens out. Okay? It doesn't change the amount of volume that's flowing through it, right? And volume in this case would be amps, right? Or the amount of electrons that's passing across an area per second. So because we only have one pathway, and these resistors are one after the other, we call that a series circuit. And again, I understand that some of you guys really got this down. And if you've really got this down, you don't need to watch these videos. They're not required. These are just to help people. Okay. So we would, because they're in series, we would call this a series circuit. Plain and simple. Okay. So let me label that up here. We got our series. Series circuit. Okay. So now, why the previous video's math is so important is because the only thing we have to remember about a series circuit is that, and for any circuit for that matter, and this is maybe where I'm a little bit different in the way I teach this than others, is that we have what's called a circuit. I would say what I call a circuit. You got to get a C in there. Constant. Okay, there is a circuit constant. That is a value that doesn't change at all, no matter how many resistors or devices you put on the circuit, it doesn't change. Okay, and the circuit constant for a series circuit is amps, which goes back to the video. There's a bottleneck, but that doesn't change the volume that is passing through the circuit. Okay. The other values on the circuit when we apply, uh, that we apply, such as voltage, they do change. Okay. They're not constant. Amps is constant. So, how would we work a circuit like this if we, and I want to leave this, if we give ourselves some values? So, let's give ourselves a voltage of 24 is a good battery voltage DC. All right. And that's, of course, going to equal E. And we give ourselves a resistance for R's1, R2, and R3. And this is where I would ask the class to give me some values. But we'll just make it simple and just say 10, 10, and 10. And my little funky omega sign. Okay. And now, because we have these two values, we can figure out the other values. In fact, that's the only way. I couldn't just sit here and guess at an amperage, okay? Because it would be wrong. Because we have these other two numbers, right? Because we have the 24 and we have the 10 and the 10 and the 10. The amperage that the circuit has depends on those. Okay? So, circuit constant amperage is what we're going to try to find. And the way we do that is we need to find RT. Okay? And like I said, I made it easy because in a series circuit, amperage, or I'm sorry, in a series circuit, resistance just adds up. You can take that to the bank. You can check that in the Uglies book, but I'm going to go ahead and do that in my head and say that RT, or resistance total, is 30 ohms. And man, you know what? I might have to split this video into 3 so that you're not sitting there latched to the computer all evening. So far, series circuit, we have our amps. I'm sorry, we don't have our amps. That's what we're trying to get. But we do have our volts, which is 24 volts DC, and we have our resistance total. And with those two numbers, we can find our amps, right? So what was the math? Remember from the last one? It was E divided by R equals I, right? And if we needed to, we could go back to the pie chart. Okay. And if we do that, 24, I'm going to do that in the calculator. If we do that in the calculator, we would hit 24 volts divided by 30 ohms, and we would get an amperage of 0.8. All right, so we did the math, and we got I equals 0.8 amps. Okay, now that amperage would be everywhere on the circuit. Okay, it wouldn't matter if it was here, it wouldn't matter if it was here, here, going across the resistance. It would always be 0.8. I equals 0.8 amps. Okay, because amps is your circuit constant. And so often when we do problems with series circuits, that's what they want us to find is the amps. And it might ask a question like, let's get rid of some of this. It's all captured on video. It might ask for something like this. What is I1? Okay. And you would have resistances. So we'll just do R1 equals 10, R2 equals 10, R3 equals 10. I'll put that up here because it'll look cleaner. And it'll tell us a voltage. So right here, it'll be like E equals 24 volts, something like that. And then it'll ask what's the amperage for I1, and you would have to go through all of that math that I just showed you, adding all the resistances together to get your RT of 30, and then do your Ohm's law math to get the 0.8 amps. And then what you have to remember is amps is the same everywhere. So what I1, let's get that in a different color. What I1 is referring to is the amperage across that resistance, or R1. And likewise, if it was going to ask you what, I1 was, then it would ask you, it would be like that. In fact, that would be our next step. Okay, so we found I1, and I1 isn't a mystery anymore. It's 0.8 amps, and it is also considered IT. Okay, so now that we have IT, which is 0.8 amps, we can be asked questions like, what is E1? Okay, and do we have enough information to do that? Yes, we do, right? Because we have amps and we have resistance. And what is the equation? Amps times resistance. So 10 times 0.8 equals, need that on top of your head, 8 volts. Okay. So Now, to tie it all together, volts in a series circuit, just like resistance, because they are directly proportional to each other, meaning that they affect each other in a positive way, add up as well. So if you took the 8 volts, and remember all our resistances are 10, so we just times that by 3. I'm sorry. Let's back up then. So that 8 volts is going to be our E1. That's a crappy E1. Like I said, I dot them. Then if R2 is the same, then E2 is going to be the same. So E2 would be 8 volts and E3 would equal 8 volts. And we already got that one there. And if you add up the voltage, what do you get? Well, you get the 24 we started out with. Okay. And this is actually, let's label that right. This is actually the beginnings of understanding what voltage drop is. Because what happens is in a series circuit is the voltage gets divided up based on the resistance. So, all right. I kept it simple just for sake of time. But obviously, we can have a circuit that has different resistances, right? So we could have R1 is 10, R2 is 20, and R3 is 30 ohms, 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 right? We could keep our voltage the same, or we could say, hey, we've just hooked up a whole bunch of batteries together. 10 12-volt batteries hooked together in series would give you 12 volts, because in a series circuit, voltage adds up, just like I showed you. And if we get these weird numbers, we would still have to figure out IT. And we would do that by adding these together to get 50, right? Or 60. So RT would be 60 ohms. And then we would do our math. 120 divided by 60, which is what? I'm going to come over to the calculator again, because even though it's easy math, it should show you how to plug it into the calculator. Equals 2. Okay. So our IT equals 2 amps. Okay. And hopefully you guys are following along to see how I got that. Okay. So then if we want to find a voltage that's dropping across the resistance, we just need to apply the IT. So the I times R, and 2 times 10. So 2 times 10 gives us a IE1 of 20 volts. And then you can just go around, right? So we got E1, E2 equals 2 times 20, which is 40 volts, and E3, which is 60 volts. And what happens when you add those together? You get 120 volts, the circuit total. All right, so hopefully that helps you with series circuits. It did take a while, and so I'll probably do another video on parallel circuits, and then another video on combination circuits. So thanks for hanging out with me. hopefully you can get something out of these, and I will see you in a moment.